Sorry about that. Something went a little crazy with the computer. Alright, so for this one, we're just combining like terms on top. So 15x minus 15x, cancel out, give us 0. 6 plus 35, we get 41 over 5x plus 2 squared. That's it. That's your derivative. 2, pretty similar. Won't go over that one right now. Number 4, I want to take a look at that. Before we do, for number 3, the only thing that you would do to change this is rewrite square root of x as x to the 1/2, so we can take the derivative. And then it's pretty much like the other two. But for number 4, we want to do a little rewriting before we take the derivative. First, negative exponent, we can rewrite that as 1 over 4x minus 3 squared. All right, to make that negative exponent positive, we put it in the denominator. Then we can go ahead and multiply this out. So 4x minus 3 times 4x minus 3, if we multiply that all out, we get 16x squared minus 24x plus 9. Now it's at a point where it's a little bit easier to take the derivative. So we're going to use the quotient rule. And for this, derivative of the top is just 0. It's a constant. So I'm going to write it. You don't necessarily have to, but it's 0 times that whole denominator. That's just going to end up being 0 minus the numerator, which is 1, times the derivative of the denominator. So we get 32x minus 24 plus 0, because the derivative constant is 0, all over the denominator squared. So this whole thing ends up being 0. We get negative 32x plus 24 all over 16x squared minus 24x plus 9 squared. For now, that's good enough. We can actually simplify that a little bit, but for now, that's fine. Let's take a look down below. It looks a little more confusing, but actually it's simpler. A lot of the work is done for you. It's just kind of getting the concepts of these different types of derivatives. It gives us values for these derivatives. The derivative of f of 3, I'm sorry, just f of 3, not the derivative. F of 3 is negative 4, derivative of f of 3, g of 3, and the derivative of g of 3. So we want to evaluate each of these. If we look at number 1, we're taking the derivative of f times g. So multiplication, that means we're going to use the product rule. So product rule means that we're going to take the derivative of the first function, so derivative of f. In this case, we're doing it at a specific value, so at 3, times g of 3, right? For derivative of the first times the second, plus the first function times the derivative of the second, so times the derivative of g of 3. So that's just the product rule, except we have a 3 in there instead of x, because it's asking us to evaluate at 3. Now all we're doing is substituting in these values. Negative 4 goes in for f of 3. Negative 5 goes in for the derivative of f of 3. Negative 2 goes in for g of 3. And 6 goes in for the derivative of g of 3. So derivative of f of 3, we've got negative 5 times negative 2 plus negative 4 times 6. So 10 minus 24, negative 14. For number 2, this one's just the derivative of the sum. We found out earlier that's the easy one. We just have derivative f of 3 plus the derivative of g of 3. So substitute those values in. Derivative of f of 3, negative 5. Derivative of g of 3, negative 2. We end up with negative 7. I'm sorry, this one should be 6. So So we should get 1. All right. Well, let's skip down and look at number 4. This is a quotient. We're taking the derivative of the quotient, so we have to use the quotient rule. But be careful. This g is on top instead of the bottom like before. So derivative of the top times the bottom minus the top times the derivative of the bottom, all over the denominator squared. So now we just plug in the values. Derivative of g of 3 is 6. F of 3, negative 4, minus g of 3, negative 2, times the derivative of f of 3, negative 5, all over f of 3 squared, so negative 4 squared. We get negative 24 minus 10 all over 16, so negative 34 over 16, or negative 17 over 8. If we go back to number 3 here, we have a constant times g. We're taking the derivative of that. Remember, that's just the constant times the derivative of g at 3. The constant we just leave out in front and multiply it by the derivative. It's one of the rules we talked about earlier. So we have 5 times the derivative of g of 3 is 6, which gives us 30. You do the same thing basically for 6, except we have the subtraction. So 2 times the derivative of f of 3 minus 5 times the derivative of g of 3. Plug in the values. Here, 1 over g. So we're taking another quotient here, just like number 4. Derivative of the numerator is 0 times g of 3, but it doesn't matter, that's still going to be 0, minus the numerator, which is 1, times the derivative of g of 3, all over the denominator, g of 3 squared. Right, so same basic idea as the other one. This is going to cancel out, so we get 0 minus 1 times derivative of g of 3, so negative 1 derivative of g of 3 is 6, all over g of 3 squared, so negative 2 squared. We end up with negative 6 over 4, or negative 3 halves. Alright, your homework tonight is down here. Remember that review is due Thursday, big quiz on Thursday, and I will see you tomorrow.